the goal of this problem is not only to give you an extra example of separation of variables, but also to illustrate the concept of hidden solutions. So in particular, let's find a solution of this differential equation that goes through the point 0, 1. So in terms of separation of variables, let's cross multiply. So 4 plus y cubed dy equals 4t minus t cubed dt. And as before, let's integrate. So integral of this equals integral of that. 4 plus y cubed dy equals integral 4t minus t cubed dt, which then becomes, let's see, 4y plus 1/4 y to the 4 equals 2t squared minus 1/4 t to the 4th plus c. So technically I should have added a c and a c prime and then combined it, but I'll just do it faster. And then, well, for instance, let's turn this 1/4 y to the 4th into y to the 4th. So multiply by 4. So 16y plus y to the 4th equals 8t squared minus t to the 4th plus 4c. Ooh, I did not foresee this. But joking aside, 4c is arbitrary, so we can just replace it by c, and then we get y to the 4th plus 16y equals minus t to the 4th plus 8t squared plus c. Now, usually we're accustomed to solving for y equals something that is called explicit form, but in this case, unfortunately, we cannot do that. And technically we can. There is a formula for fourth order equations, but we'll not go there. So a lot of times in math, we cannot solve this in explicit form, but we just leave it like that, called an implicit form. Implicit form, where we have an equation with y and an equation with t, where we cannot explicitly solve this. So as opposed to explicit form, which would be y equals to, but which is okay, in our problem, because that will still allow us to draw the curve and everything and get info about our equation. But of course, we're not quite done. So we still need to plug in c. So to find c, well, remember I think we had through the point 0, 1, which meant, okay, t equals 0 and y equals 1. And then what we get is, so 1 to the 4th plus 16 times 1 equals minus 0 to the 4th plus 8 times 0 squared plus c, and then we eventually get c equals 17. So what is the answer? The answer is simply the solution is the curve y to the 4th plus 16y equals minus t to the 4th plus 8t squared plus 17. And if we want to see a picture, well, this you can usually ask Mathematica to do, or Wolfram Alpha or Desmos, and you get the following blobby curve. Looks kind of like this. So this is our solution y, which is solution of this differential equation. And of course, you may ask, well, when do you know whether to leave it in implicit form or not? If I tell you you can leave it in implicit form, then you can do that. But if I don't tell you anything, you are required to leave it in explicit form. Solve for y equals to something.